Hey, what's up guys? This is Yash once again with another video. In this video we're gonna talk about easiest method to calculate bond order. Okay, so in this video we'll study easiest method to calculate bond order of resonating structures. Bond order of resonating structures. Okay, so let's start with, first of all, what do you mean by bond order? Bond order represents the number of atoms which is present between two atoms in a molecule or any species This species, I mean to say, it can be a polyatomic radical. For example, you are having CO3 2 minus, PO4 3 minus, okay, Cr2O7 2 minus, all these things. Okay, bond order. Now, bond order represents the number of bonds which is present between two atoms in a molecule. If bond order is 1, it simply means what? There is a single bond. If bond order is 2, it means there is a double bond. And simply you come to know that if bond order is 3, it means there is a triple bond. Okay, but it is not necessary that every time you'd be having a perfect whole number. It can be a fraction, like sometime you can have 1.33, 1.5, or sometime 2.3, 2.5. Such kind of bond order you'll be having. Okay, so here mainly we'll talk about the resonating structure bond order. So talk about bond order of the resonating structure. But let me tell you some of the very important thing. In order to know the resonating structure, generally you require Lewis dot structure. Generally require Lewis dot structure. Okay, generally require. But let me tell you very frankly that if you don't know Lewis structure, then too you draw the resonating structures. It's my challenge to you that you can solve the bond order question of any of the resonating structure, which are the radical of hydra acid or any of the resonating structure of anions. You can solve it within 1 minute. So let's have the formula first. Bond order is equal to valency of peripheral atom plus charge on anion radical divided by total number of peripheral atom. But you keep one thing in your mind, and this is only and only formula for resonating structure, in which you are generally having the bond order in fractions. Okay, bond order in fraction. This will be quite easy for you. Okay, now let's discuss about this formula. In this formula you are having valency of a peripheral atom. So first of all you should know what is an peripheral atom. Okay, So you should know first what is peripheral atom, and then second you should know the valency also. Valency, I think you would be knowing the number of electrons which are generally present in outermost shell. Okay, generally present in outermost shell, and we take if it is less than 4, then you consider it directly. If it is more than 4, then you just deduct it from 8. Okay, like suppose if any atom is having 7 electron in its outermost shell, so its valency will be 8 minus 7, that comes out to be 1. And if it is having 4 or less than 4 electrons in its outermost shell, then you have to directly consider it as its valency. But if it is more than 4, then you have to just deduct it from 8 in order to get the valency. Let's have an example. Suppose we are having carbonate ion. So this is what carbonate ion. So you can see the peripheral atom over here is oxygen. Now you'd be having a doubt why oxygen is only considered as a peripheral atom, because when you draw the Lewis dot structure, carbon is at the center. So this is O, this is O, and this is O. Okay, so this is the Lewis dot structure of carbonate ion. Okay, so you can see these 3 oxygen atoms are present at the periphery. Okay, this is the one, this is second, and this one is the third one. Now you'd be having a doubt, so what about the bond order of neutral species? Neutral species. Okay, so I've given you a simple formula for that. Okay, you can draw its structure, or in some of the case we'll also be using MOB, that is molecular orbital theory, which I'll teach you later on. Okay, so let's proceed towards our examples. So we'll have first example, that is carbonate ion. So let's apply the formula. Bond order is equal to valency of the peripheral atom is 2 plus, now charge on radical is minus 2, and it is divided by total number of peripheral atom, that is 3. So it comes out to be 2 minus 2 by 3, which is 6 minus 2 by 3, and it comes out to be 4 by 3, that is 1.33. Okay, so this is the first example. So you got the answer. The bond order is 1.33, very close to a single bond, or you can say greater than a single bond. Now we'll have our second example. The second example is, you can have phosphate ion, PO4 3 minus. So bond order would be, first one, the formula says we need to first calculate the valency. So it's oxygen, so 2 plus minus 3 divided by total number is 4, so which is comes out to be 2 minus 3 by 4, which is 5 by 4, comes out to be 1.25. This is the bond order of phosphate. A third one, the example is nitrate ion. Okay, so again you are having bond order, that is 2 plus minus 1 divided by 3. So it is 2 minus 0.33. It comes out to be 1.64. Okay, so this is the third example. Now I can proceed to the fourth one. You can have sulfate ion. So again, bond order, the valency of the surrounding atom is 2 plus charge on radical is minus 2 divided by total number of peripheral atom, that is 4. So it will be 2 minus 1 by 2, that comes out to be 2 minus 0.5, which is 1.5. okay, now the next one is we need to find out the bond order of sulfide ion. So again we'll use the formula 2 plus charge will be 2 by 3, so it is 6 minus 2 by 3, which comes out to be 4 by 3, and answer is 1.33. okay, so next one you are having is the sixth one. It is ClO4 minus. This is called as perchlorate ion. Okay, so you can use bond order formula. The surrounding atom valency is 2 plus minus 1 divided by 4, so it is 2 minus 0.25, which comes out to be 1.75. the bond order is coming closer to 1.75. I can just draw the structure so that you'll understand in a better way. This is Cl double bond O, single bond O. These oxygens are having negative charge. This is the mistake. Only one oxygen atom is having a negative charge, rest all are having double bond. So this is the structure of perchlorate ion. Okay, it is derived from perchloric acid, which is nothing but HClO4. Okay, so by using this formula you can solve any of the problem of the acid radical. Okay, so please keep in mind, you can find out the easiest answer of any of the acid radical. Okay, I hope you understood the video thoroughly. Okay, and share it with your friends so that even if they are having any doubt, their doubt will get cleared. And don't forget to press the bell icon. Please share and subscribe. Thanks a lot for watching.